All right, we're looking at Chapter 11 on radicals, and this is section 11.4. We're going to rationalize denominator. So what does rationalize the denominator mean? Well, it means to get the denominator so it doesn't have a radical in it. So as we can see, for example, here, 1 over the square root of x, that has a radical in the denominator. And what we want to do is get rid of that. And so what we need to do is called rationalizing the denominator. So with the square root, basically we're going to multiply the denominator and the numerator by exact radical that's in the denominator. So in this case, we had 1 over the square root of x, so we multiply the numerator and denominator by the square root of x. And then what happens is the denominator is now going to be just the radicand, because the square root of x times the square root of x is the square root of x squared. And when you take the square root of something squared, you just get the radicand. But in the numerator, 1 times the square root of x stays the square root of x. And so that's how it's going to work. We're just going to multiply by the same thing that the denominator is with the radical, and then it basically cancels out, and then we just keep that radicand down here. So for this one, what we're going to do is we're going to multiply by the square root of 3 over the square root of 3. Now we know the square root of 3 times the square root of 3 is going to be the square root of 3 squared, and so we know that when we take the square root of something squared, we just get what's there, and so that's 3. Now when we multiply radicals, we just know we can bring everything underneath, and we take 5 times 3, and we get 15. Now there's nothing here that's squared, the 3 or the 5, and so it just stays square root of 15 over 3, and we've rationalized that denominator. All right, what about this one? Well, this one we can do several things. First, we can reduce. We can take this 4 here, and that goes in here once, and it goes here 4 times. Then let's think about this. What is the square root of 20? Well, before we even do that, well, let's just take and multiply by the radical 20 over 20, because there's a square root of 4 we can take out of here. But what we're going to do is we're just going to take and say, okay, well, we don't realize that. And so we're just going to take the square root of 20 times the square root of 20. And that happens to be basically the 20. And we still have this 4 out in front. So it's going to be 4 times the square root of 20. Now in the numerator, that's just 1. So now we have the square root of 15 times the square root of 20. Well, 15 times 20 is going to give us 300. Okay. Now before I do anything else with this 20 and multiplying times 4, I'm going to look and see, well, what is 100 times 3? Well, 100 times 3 is 300. And I can take the square root of 100, because the square root of 100 is 10. And then we still have the square root of 3. So we'll have 10 square root of 3 over 4 times 20. All right, so now what happens? Well, now what I'm going to do is I'm going to say, well, that 10 will cancel here once, and it'll be 2 here. And so in the numerator, I get square root of 3. In the denominator, I get 2 times 4, or 8. So that's taking this expression, multiply by the square root of 20 over the square root of 20 to get rid of the radicals, and then after that simplifying the radical on the numerator to make it so then we can reduce it to the most lowest form possible. Now what do we do though if we have a denominator that has a higher power root? So when we look at this one, these are, if we remember, the square root is the same thing as having a 2 here. So we can either put a 2 there, or we can just leave it as square root. What happens if we have a 3 or a 4 or 5 or something here? Well, what we have to do then is we have to be sure to multiply by an appropriate value in the numerator and denominator to have that root of what's in the denominator be the same as the power of the radicand inside. And so then when you do it, that's basically going to cancel. And so what we see here is if we have 1 over, and here we have the 4th root of x cubed. Well, we need to get this to a 4 because we have a 4 here. So what we want to get eventually is this and this to be the same, because if you remember, we had the square root of x squared, and remember the square root is 2, and so those became the same. And so what we had done is we took the square root of x times the square root of x. We got the square root of x squared. That was the same. Well, now we have to figure out what do we have to multiply in this case to get to a 4. Well, we're going to have to multiply this one times the 4th root of x, because when we multiply this and this, it's going to take 3 plus that 1, and we get 4. And then in the numerator, we take 1 times the 4th root of x, and we get the 4th root of x. Now down here, that's a special thing, you know, the fourth root of something to the fourth, that just becomes the x, okay? So that's what we're trying to get down to, is the most simple form of x. So then we have the fourth root of x over x. Well, that's if we have a 3 here and a 4 out here. What if we have a 2 instead? Well, we know we have to get to a 4, so what do we have to take this x squared times to get an x to the fourth? Well, we have to multiply it by an x squared again, so when we multiply those two, we add and we get 4, and we still have to take it times the fourth root, so we do the numerator denominator the same, and so we'll have the fourth root of x squared on the numerator, and the fourth root of x to the fourth in the denominator. Those basically are going to cancel, and we just get our x. But now notice here we had x to the first, here we have x squared, and so the last one I want to kind of show you is here we have an x to the first. And again, we need to get to x to the fourth because we have a 4 here for our root. And so what do we have to multiply x to the first by to get x to the fourth? Well, that would be the x to the third, because we'll take 3 plus 1 to get our 4. And so we do the numerator and denominator the same, so we get the fourth root of x cubed over the fourth root of x to the fourth, which is just x, and so that would be how we simplify that one. So another thing we can do is we have to rationalize denominators that have not just the radical, but some other number plus or minus the radical. So, you know, we're going to have plus or minus it. And so what we have to do here is we have to use the conjugate, okay? So we're going to rationalize denominators of the type a plus or minus the square root of b, whether it's, you know, plus or minus, by multiplying the numerator and the denominator by their conjugate. So what is a conjugate? Well, if a plus the square root of b is the original, the conjugate is a minus the square root of b. And you'll see why we do this because it's going back clear to FOIL. When we FOIL these, what happens is we're going to have a plus the square root of b times a minus the square root of b. And so we'll have a times a, we get a squared. And then we'll have a times the negative square root of b, so it's negative a squared of b. Here, that'll give us a positive a squared of b. Guess what? Those two cancel, so we get rid of that middle term, which has a square root still. And the square root of b times the square root of b is going to be the square root of b squared, or just b. And because it's plus times the minus, it's going to be the minus, okay? And so that's why we're doing basically the opposite sign. So if we have the plus, the conjugate is a negative. If we have a negative, the conjugate is a positive. So if we initially had this fraction here, 1 over a plus the square root of b, the conjugate is a minus the square root of b. So we multiply numerator and denominator by that. And so numerator, that's just a minus the square root of b. And we've shown that when we do this, you know, we have the a squared, then we have minus a square root of b plus a square root of b, and then minus the square root of b squared, which gave us a squared. That cancels that. And then minus, well, here's a 2, so that's just b. And now notice we've gotten rid of the radical in the denominator. We still have a numerator, which is fine because that's what we want to do, is get it to the numerator and get rid of it in the denominator. And so that's when we have the plus. If we have the minus here, we multiply by the positives, numerator and denominator, and then we get an a plus the square root of b over the same denominator. So it doesn't matter, you know, the initial one, it's always going to have the same denominator here, a squared minus b. All right, so now what we're going to do is we're just going to do a bunch of examples, and it's simplifying by basically getting rid of the radical in the denominator. So we're rationalizing the denominator, okay? So if we look at this, what is the cubed root of 4? Well, the cubed root of 4, well, what is 4? Well, 4 is really 2 squared, okay? Now remember, we have to multiply by something to get this to be a 3, so that means we'll have to multiply by the cubed root of what? Well, we'll have to multiply by the cubed root of 2. And then 2 squared times 2 is going to give us the cubed root of 2 to the third. And then it's not going to write here. And so then when we get done with that, that's just 2. So that means we'll have to multiply here by the cubed root of 2 over the cubed root of 2, okay? Now, again, when we do that times this, what we end up with is on the denominator, we'll have 4 still times, and that's just going to be 2. Now, the numerator, we're going to have the cubed root still, And it only works if we have the same roots here. So if we have different roots, then you'll have two different radicals, but because they have the same root, we can just multiply. We take the 5 times the 2, and we get 10. And so then we get the cubed root of 10 over 8. Okay. So the key was seeing that 4 is 2 squared. We need to get to 2 cubed, so we had to multiply by the 2, and then we have our value at the end, which is just 2. Now, if you didn't see that, what you'd have to do is you'd have to take that to the, put a 4 here and take it squared, and when you do that, that's going to change some things up here and change the values, and so you'd have to do some reducing, and so we want it to be in the smallest terms possible, and that's why we did it this way. Well, what do we have here? Well, here's the square root. So the square root means we just have to multiply by that same square root. So just the square root of 5. And so we do that in numerator and the denominator. And so in the numerator, we get square root of 2 times the square root of 5 is square root of 10. Now here we still have a 3, and square root of 5 times the square root of 5 is square root of 5 squared, or if we simplify it, that's just 5. And so that's the square root of 10 over 15. All right, so here's another one. What is the square root of 9? Well, you know, this one's one of those tricky ones. You kind of have to know what the 9 is. Well, 9 is 3 squared, so the square root of that, well, that's just 3. So you can either know the square root of 9 is 3, or if you broke it down and said, well, hey, that's really 3 squared, and that just is 3. And so that gives us 4 plus 2 square root of 3 over 3. And we didn't have to do any multiplying of radicals, and so it was so much simpler. So sometimes you have to think about what the question is asking, and can you simplify it? And if you can, then you just simplify it, and then you just rewrite the expression as that. What about this one? Here we have the square root of 13. Well, 13 is a prime number, so what we're going to have to do is multiply by the square root of 13 over the square root of 13. Okay. So the denominator, that gives us 4, and the square root of 13 times the square root of 13 just gives us 13, because that'll give us 13 squared, and when the square root of that is just 13, and so that's our denominator. Now here, we're going to have to take that square root of 13 and distribute across both of those, okay? So the first one, we'll have 2 square root of 13, and we have minus 5 square root of, well, 5 times 13, it looks like 65, okay? So in the numerator, we have 2 square root of 13 minus 5 square root of 65, all over 4 times 13, so that's going to be, what, 52, okay? And so that would be our final answer, because we can't reduce any of this, and so we would just leave it at that, and we've rationalized the denominator. There's no radical down here, and so with that one, we would be done. All right, what about this one? Well, here we've got the two things. We've got a part here and a part here separated by a plus. So what that means is we're going to have to multiply by the conjugate. Well, what is the conjugate? Well, in this case, it's kind of weird because it's going to be 3 square root of 5 minus square root of 2. All we do is we change it from a plus to a minus. That's the conjugate. And so what we do down there, we also do up here. And so in the numerator, we're going to take that 5 and distribute to both of those. So we have 5 times that. Well, 5 times 3 is 15. Then we still have the square root of 5. Then 5 times a negative square root of 2 is going to be a negative 5 square root of 2. Okay. Now, what do we have here? Well, we have this times this. We have 3 times 3. Well, that's 9. Square root of 5 times the square root of 5. That's going to be square root of 5 squared, or just 5. So then we have the outer, so now we'll take that times that, and so that's going to be minus 3 square root of 10. Then we'll take the inner, and that's going to be plus 3 times the square root of 10. And then we'll take and do the last, and that's going to be minus, and then the square root of 2 times the square root of 2 is going to just give us 2. Okay, well, looky here. We get rid of our radicals, which is good. So we have 45 minus 2, which is 43. And so that then is what our denominator is here. Okay, and so that one, you know, that's our first conjugate one. And we had to remember, you know, we had to go ahead and FOIL everything out. and get it done. Or we could have remembered, we take that one and square it, and then it's going to be basically that one squared as well, because in this case we have square roots on both of them. So you kind of have to look at it as far as what it is. Sometimes you're going to have, first one squared first one squared minus the second one squared, and that's going to be what happens when you have square roots on both the term A and term B, if you want to call it that. Now this one's going to be a little different because we're multiplied by the conjugate, but there's no radical here, so it's just going to be 4 plus 3 square root of 3 and 4 plus 3 square root of 3. Okay. So again, we're going to distribute across. So 3 times 4 is 12, plus 3 times 3 is 9, square root of 3. Now this one we can do, remember it was a squared minus b, and we could do that. But sometimes I think it's just easier if we don't remember everything, just remember the FOIL. And so let's do it with just FOIL. So we're going to take 4 times 4, that's the first. So that's going to be written out 4 times 4. Then we'll do the outer. So we'll take 4 times 3 and times radical 3. So it's going to be plus 12 radical 3. And then here, that's going to be minus, that's going to be 12 radical 3 when we do the inner. And when we do the last, we're going to have minus, and we'll have 3 times 3 is 9, times square root of 3 times the square root of 3 is 3. So here we have that cancels that. We'll have 16 minus 27. And so that's going to give us a negative 11. And so our denominator then is negative 11. Okay. And our numerator is still just 12 plus 9 square root of 3. We can't simplify anything here. No canceling can happen. And so then that would be our final answer. All right, what about this one? On this one, I'm just going to make and remember that negative, maybe I'll change that to a plus, and I'll put the negative up here. So that way, remember, you can put the negative here, out front, or down below. I'm going to put it up here. And that way I don't forget when I do my distribution. And so here we're going to multiply by the conjugate again because we have that kind of a problem. And this time we're going to multiply by 4 plus 4 square root of 2 over 4 plus 4 square root of 2. Okay. And so when we do that, we're going to have a negative 4 times that and a negative 4 times that. And so it's going to be negative 16 minus 16 square root of 2. And down below, well, that's going to be, we multiply that times that, and we're going to have 4 times 4. Then we multiply this times this, and that's going to be plus 16 square root of 2. This is going to be minus 16 square root of 2. And then this one is going to be plus, or plus, it's going to be minus. And it's going to be minus 16, and the square root of 2 times the square root of 2 is 2, so times 2. So those cancel like we hoped, and now we have 16 minus 32 is equal to a minus 16, and we have our thing there. Now, this one, amazingly enough, we have something we can cancel here. And what we can do is we can say, well, this we can do this two ways. I think maybe the first way is I'm going to factor out a negative 16 out of the numerator because I see that that's a common term. And if I do that, then I have 1 plus square root of 2 all over negative 16. So that's going to probably be the easiest way. And then when I do that, I see that that cancels that, and I could just get 1 plus square root of 2. Okay. And so this one had a little bit more we had to do. We actually had to do that factoring out and then simplifying after that. All right, what about this one? Well, we're going to again multiply by the conjugate. Now the conjugate is going to have a plus between them. And so I have square root of 7 plus square root of 2 multiplied on numerator and denominator. And the numerator has 2 and the denominator has 2. So we're going to have to FOIL the numerator and we're going to have to FOIL the denominator. So we're going to do all these products. So the square root of 14 times the square root of 7, well, that's going to be the square root of 7 times 14, 98. And then we'll have the square root of 14 times the square root of 2, so that's going to be plus the square root of 28. And here that's going to be minus 2 square root of 7. And this is going to be minus 2 square root of 2. All right. What about down here? Well, we're going to do the same thing. Now this time, it's going to get rid of all of our radicals, so we won't have any radicals left. So square root of 7 times the square root of 7, well, that's 7. And then we'll have square root of 7 times the square root of 2, so it's going to be plus square root of 14. And then here we're going to have minus the square root of 14. And then here we're going to have minus 2. Okay. All right, so let's simplify here. So this cancels this. We have 7 minus 2, so that's going to be a 5. Now, can we reduce anything here and make it simpler? Well, what is 98? Well, 98, if we divide that by 2, that's going to be 49. So that's 2 times 49. Well, that I can simplify because I know the square root of 49 is 7, so that's going to be 7 radical 2. So I'm kind of going a little higher here. All right, well, what is 28? Well, that's going to be square root of 4 times the square root of 7, because 4 times 7 is 28. Well, square root of 4 is 2 times the square root of 7. And then I can bring that up here. That still is and that's a plus in between. And then I have a minus 2 square root of 7 minus 2 square root of 2. Now I've got like radicals. I've got a radical 2 here, a radical 2 here, and a radical 7 here, and a radical 7 here. Well, 2 radical 7 minus 2 radical 7, those are gone. Then I have 7 minus 2 is 5 radical 2. And so now am I done? No, because guess what? Now my 5 cancels a 5. And that whole thing breaks down to just the square root of 2. So all of this, rationalizing the denominator, gives me just the square root of 2. All right. What about when we have variables only? We don't have any numbers really here. Well, we're going to do the same thing. We're going to multiply by the conjugate. So that's going to be square root of a minus the square root of b. And that's the square root of a minus the square root of b in the numerator as well. And so when I multiply here, I'll have a times this and a times that, and then a square root of ab times that, and a square root of ab times that. And same down below, I'll multiply here, and here, and then here, and then here. So in the numerator here, I have a times the square root of a. Well, that's a square root of a. Then a times this is going to be minus a square root of b. Now if I take square root of ab times the square root of a, that's going to be plus the square root of a squared b. And then if I multiply here, that's going to be minus square root of ab squared. All right. Now what about the denominator? So we've simplified the numerator and distributed it out. Well, here we have square root of a times the square root of a, so that's going to be just a. Now remember, when you take this one, b times, or square root of b times square root of a, that's just square root of ab. And this one's going to be minus the square root of ab. So we don't even have to write it. We've got to the point, I think, we don't need to write that every time. But we do write this one, and it's going to be square root of b times the square root of b is just b. And so it's a minus b. All right. Well, do I see anything I can simplify? Well, notice I have the square root of a squared here. So really we have the square root of a squared times the square root of b. And here I have the square root of a times the square root of b squared. Okay, so that could be simplified. And so if I see this, I have what? A square root of a minus a square root of b plus, now here, square root of a squared is just a, so it's going to be a square root of b. And here I have minus b square root of a, because square root of b squared is just b, and I still have times square root of a. And so what does that do? That gives me some things that cancel. Well, a squared of b and minus a squared of b cancel. And so that helps. And now I have all over a minus b. Now I am kind of looking ahead here. I see a square root of a here and a square root of a here. So those are like items. I'm going to factor out that square root of a. And then I have left over what? Well, I have an a here and a minus b here. And then on the denominator, I have a minus b. Now guess what? A minus b is a factor. That's a factor. And so that gives me just the square root of a. All right, so that one was another nice one where we start with a whole bunch of stuff and we end up with just the square root of a. All right, how about this one? All right, well, we're going to multiply by the conjugate again, so that's going to be a, well, that's going to be times a minus the square root of b over a minus the square root of b. So again, I'm going to distribute and do FOIL. So I'm going to multiply here, then I'm going to multiply here, and same in the denominator. But remember, I'm only going to really do the first one and the last one because everything in the middle all cancels out. So we don't have to worry about those on the bottom because we're multiplying by the conjugate, so we don't have to worry about that. But the numerator we do. So a times a, well, that's a squared. A times the negative square root of b is going to be minus a square root of b. Then here I have a times the minus square root of b. And here I have a minus times a minus, that's going to be plus, and the square root of b times the square root of b is b. And then that's all over. Now I have a times a is a squared, and the b square root of b times the square root of b is going to give me just b, and I remember it's going to be a minus, and so I have a minus b here. All right, so what do I have now? Well, now I've got a squared minus 2a and then square root of b and then plus b. All right. Now, does that kind of ring any bells? Well, you know, we can leave it as this, and don't forget we still have that a minus b here. Or if we remembered, hey, you know, that times that, that's just going to give us, and we could write this as or, and we have a minus the square root of b squared over a minus b. Okay, and so I think depending on how that says to either, you know, multiply it all out and see if anything cancels, do that. Or if we see this, we have, you know, this one and this one, those are the same. So that's really just that quantity squared over a minus b. Nothing can reduce here either. And so I think either one of these options is good for an answer. Okay, so whatever you come up with, as long as you have the right numbers when you've squared it and you have, you know, one here and one here, so you have a minus 2 here, and then you took the square root times square root, just got the b here, then that would be fine. Or if you saw at the beginning, you know, we could just say, well, that term times that term, well, that's just that term squared, and then over our denominator of a minus b. All right, what about next one? Here we got 11. Okay, so this is going to be similar to the last one. You know, we're going to multiply by the conjugate. So we're going to multiply by a square root of b plus b square root of a over a square root of b plus b square root of a. And we're going to FOIL. So we're going to multiply here and here and then here and here. So a times square root of b. So that's going to be a squared square root of b. And a times that's going to be plus ab square root of a. And then here we're going to multiply that. It's going to be minus ab squared of b. And then here that's going to be a minus b squared and then square root of a. Okay. And then all over. And so remember, we're just going to take first times first, last times last, because all the middle terms are going to cancel out because we're multiplying by that conjugate. Okay, so a times a is a squared. Square root of b times the square root of b is b. Now here we have a minus. And you have b times b, so that's a b squared. And square root of a times the square root of a is a. Okay. All right, so what do we want to do from here? So here, I see I have a square root of b and a square root of b. I have the a here and a square root of a here. So maybe what I'm going to do is add like terms. All right, and so if I add the two square roots here, so I'll have a, well, let's do the a's first maybe. So we'll have the square root of a times what? Well, we have ab minus b squared, okay? And then we have plus the square root of b times what? Well, we have a squared minus ab. And then that's all over a squared b minus b squared a. Okay. All right, moving on. Let's see, can we do anything here? I see that I can factor something here. I can factor out an AB here. And what does that leave me with? A here, because the A times AB is going to be A squared B minus, and if I took out an AB here, I have a B left, okay? So that looks good. So is there anything I can do up above that would help me with that? Here I could factor out a B. Here I could factor out an A. And so I think I'm going to run out of room, but that's okay. And so if I factor out a B here, I'll have B, and then I'll have square root of A times A minus B. Okay, because if I take a B out of here, I get A, take out a B out of here, I get B. And so I have that. And then here I've got plus, now I want to take out an A because there's an A in common in both of those. And then I have square root of B. And then I have A minus B again. And then that's all over AB times A minus B. Okay. Well, what can I do now? Well, I see I have A minus B that will cancel out here, and here, and here. So I've got, if I factored it out, then it might look better, but I know that if it's in this term and it's in this term, then I can factor it out in front and cancel in the denominator. And what does that give me? Well, that gives me B square root of A, and then plus A square root of B all over AB. Now here, there's nothing else I can do. There's nothing common in both of these that's also in common here. And so then that would be my final thing. So this one, you had to do a little more work and start seeing that you could factor out more things as you went along. And then you get to your final simplified answer here. So when it says simplify, you really do have to simplify as much as possible. And so, you know, looking here and seeing, oh, there's a B here. Maybe if I pull that out because I see I have an A minus B, that clued me in as far as what I might want to try to get to. All right, what about the next one? Here we have back to numbers again, yay. So what are we going to do? Well, we're going to multiply by the conjugate as usual. So that's going to be 4 radical 3 plus radical 5, and 4 radical 3 plus radical 5. And so we just distribute in the numerator. And remember, we're just going to do the first and the last now. Now that we've done this so many times, we know that's what's going to be. And so in the numerator, 4 times 4 is 16, then radical 3, and then 4, it's going to be plus 4 radical 5, all over. Now here we have 4 times 4 is 16 times 3, and then we have minus 5, okay. So 16 times 3 is going to be 48 minus 5. So that's going to give me 43. Then I still have 16 radical 3 plus 4 radical 5. I could pull out a 4 here, but this isn't divisible by 4, so I would leave it at this stage right here and just have 16 radical 3 plus 4 radical 5 all over that 43. So a lot easier than this one because there's numbers that we could simplify and do that. But sometimes you have to work with variables as well. All right, I think this is the last two. So again, we're just going to multiply by the conjugate. So we're going to multiply by 3 radical 2 minus radical 3 on the denominator and 3 radical 2 minus radical 3 in the numerator. So the numerator we have to completely FOIL because we don't have conjugates there. And then the denominator, because they're conjugates, we can just do that first and last. And so let's do that. So 3 times 3 is 9. Square root of 2 times the square root of 2 is 2. And we have minus. Square root of 3 times the square root of 3 is 3. And so we have 18 minus 3, which is 15 in the denominator. Okay, well, what about the numerator? Well, here we have 4 times 3, so that's going to be 12. Radical 2 times radical 2 is 2, so that's nice. Then this times this, so that's going to be minus 4. And then it's going to be radical 2 times radical 3, so that's going to be a radical 6. And then we have the inner, so that's a 3 times 3, so it's going to be plus 9 radical 2. And then here it's going to be minus 3 radical 3. And so now, what do we have? Well, we can multiply this. That goes to 24. This is just 4 radical 6, so that doesn't change anything. And then 9 radical 2, so plus 9 radical 2, and then 3 radical 3. So this one we can't simplify too much. And so we just get 24 minus 4 radical 6 plus 9 radical 2 minus 3 radical 3 all over our 15, okay? And sometimes that's what you get. You have 4 terms in the numerator. You know, a lot of times when we did it, some of them canceled or added together. This time it didn't, and so therefore we have 4 terms. All right, what about the last one? Again, we're going to multiply by the conjugate, which is 5 minus 5 radical 2, and 5 minus 5 radical 2 in the numerator. So we're going to distribute by FOIL here. And we're just going to multiply first and last down here. So 5 times 5 is 25. Here we have 5 times 5, so this will be a minus 25 times 2. Well, that's going to be 25 minus 50, so that's a negative 25. Okay. Well, what about the numerator? Well, here we have 5 radical 2 times 5, so that's going to be 25 radical 2. Then we'll have this times this, so that's going to be minus 25 times, well, here radical 2 times radical 2 is 2, okay. And then inner, we have a radical 3 times 5, so it's going to be plus 5 radical 3. And then the last, so it's going to be a minus 5 radical, and that's going to be 6, 2 times 3, okay. What do we have? Well, we've got a radical 2, just a number, a radical 3, and a radical 6. So again, it's going to have, it looks like 4 terms that I see here. So yeah, so I don't think there's anything else I can simplify yet. Let's see what we have though. All right, so we have 25 radical 2 minus, and then that's a 50, then plus 5 radical 3, and then minus 5 radical 6, all over a negative 25. Oh, I see one thing I can do. There's, all of these have a 5 in common, and this has a 5. So if I took out, let's say a 5, I mean, we could take out a negative 5 to make this positive and then have only negatives here, or we could just do that. Let's just take out a 5 for now. And if we take out a 5 here, that's 5 radical 2, and then minus, and then it's 10, then plus radical 3, minus radical 6. And so here, one of those cancels and have 5 here. And so now we have 5 radical 2 minus 10 plus radical 3, and then minus radical 6, all over a negative 5. Okay, and again, if we wanted to have maybe the number here first out in front and have it positive, we could have taken out the negative, but you know, it's not really a matter of what's right or wrong. I mean, another way we could write this is, say, we could say, well, that's 10 minus 5 radical 2 minus radical 3, and then plus radical 6 all over 5. And all we did was we took a negative 1 times the denominator and a negative 1 times the numerator, and then put that 10 out in front. So either way, it really doesn't matter. You know, both of these are correct. It just kind of depends on if you want to see it a different way, you can do it the other way. All right, so that's all I have for this section.